From Kitty Hawk to Cape Kennedy. NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report.
One of the best ways to find out what happens inside the Gemini spacecraft during a flight is to look over the shoulders of two engineers. They're entering a simulator at McDonnell Aircraft in St. Louis, where Gemini is built for NASA. Once the two men are seated in the craft, they begin the simulated pre-launch check. First, they look at the escape systems. Here, the D-ring for emergency seat ejections below 15,000 feet, and the abort control handle to be used above this altitude. After a final check on their instruments and communication links, the crew reports all systems ready for launch. At T plus 153 seconds, the first stage falls away. The second stage engine cuts off at T plus 337 seconds. And the command pilot separates the spacecraft from the second stage. They are now in orbit. The right-hand astronaut is a systems manager. He monitors all the spacecraft systems and carries out the onboard experiments. Here, for instance, is part of the computer used in rendezvous and docking and re-entry. There is other special equipment. A so-called swizzle stick stowed overhead enables the pilot to flick switches and rotate selectors on the other side of the cabin, thus freeing the second pilot temporarily. A drinking water pistol enables the astronaut to drink normally or through his helmet visor. Toward the end of the mission, the crew prepares for re-entry and recovery. The command pilot separates the equipment adapter. Another switch arms and automatically fires the retro rockets to slow the craft. 45 seconds after they commence firing, the retro rockets are jettisoned. Using the attitude controller and the flight director indicator, the command pilot rolls the spacecraft 180 degrees so that the horizon is visible in the upper portion of the cabin window. The craft now re-enters the Earth's atmosphere. At 50,000 feet, the high-altitude drogue chute is released. At 10,000 feet, the command pilot deploys the main parachute and places the spacecraft in a position parallel to the water for landing. Finally, as the spacecraft touches the water, the main parachute is jettisoned. From liftoff to splashdown, Gemini is a complex operation, a perfect blending of man and machine. Simulators have been used in research for many decades. They create laboratory-controlled conditions that can be repeated easily and economically for prolonged study. This giant 400-foot-long gantry is one such simulator and is called the Lunar Landing Research Facility. It is being used by scientists and research pilots at NASA's Langley Center to develop techniques for landing on the moon. Suspended from a 25-story structure is a rocket-powered research vehicle. In it, a pilot can ride and practice the lunar landing maneuver from an altitude of about 180 feet to touchdown. A special traveling crane supports 5/6 of the vehicle's weight. The remaining 1/6 of gravity, matching lunar conditions, is provided by the craft's rocket engines. From unusual devices like the Lunar Landing Research Facility, scientists are accumulating the knowledge and experience which must come before the first Apollo expedition can land men on the moon.
This has been an Aeronautics and Space Report, presented by NASA, the National Aeronautics and Space Administration.